LLMs have the ability to generate synthetic training data, which can be used to enhance the performance of machine learning models. By leveraging the power of LLMs, we can overcome the limitations of scarce or low-quality training data and improve the effectiveness of their models. By leveraging the vast knowledge and language understanding of LLMs, we can generate synthetic data that closely resembles the original labeled data. This augmentation process involves expanding the dataset by creating new data points with similar meanings and characteristics, while keeping the original labels intact. By doing so, we can increase the size and diversity of the dataset, which can improve the performance and robustness of our classification models. LLM-based data augmentation offers a valuable approach to enhance the effectiveness of machine learning models when labeled data is scarce. When dealing with classification models, we may have a limited amount of labeled data. In such scenarios, we can utilize LLMs to generate additional data points with similar labels. For instance, we can take one record and expand it into 3 records with similar meanings, while ensuring that the labels remain unchanged. For example, let's generate data using the seed record, "It is a nice movie." You can see that the outputs from the LLM are, "This movie is really enjoyable, it's a great film," and "I loved watching this movie." These sentences are completely different from each other, yet they preserve the original meaning. Assuming you have 100 valuable labeled records, using an LLM, we can scale it up to 10 times within 1 minute. This means you can generate 1,000 additional data points with similar meanings, expanding the dataset quickly and efficiently. Another use case is generating text for data exploration. For instance, let's consider a scenario where we aim to build a spam mail detection system through data exploration. We want to explore if unsupervised methods can help identify potential spam mails. In this case, we can utilize an LLM to generate some typical text that exists in spam mails. We can then convert this generated text into embeddings and search for similarities within our dataset. For example, some typical spam texts could be, "Congratulations! You've won a luxury vacation package worth $10,000, and click here to claim your prize and become an instant millionaire." To proceed, we can split the emails using a sentence tokenizer. We will then calculate the cosine similarity against the dataset using these sentences to determine if we can discover any unlabeled data that exhibits similarities to known spam texts. On the other hand, we may encounter multilingual problems where LLMs can be of great assistance. We can provide an English seed record and ask the LLM to generate similar text in another language. For instance, we can request the LLM to generate "How to open a bank account" in Japanese. As expected, the LLM can generate some accurate records. Expanding on this concept, LLMs can be valuable tools for cross-lingual data generation and translation tasks. They can help bridge the language gap and generate text in multiple languages, enabling us to explore and analyze data in different linguistic contexts. This capability opens up possibilities for various applications, such as cross-lingual information retrieval, language transfer learning, and multilingual natural language understanding. If you are dealing with a named entity recognition model, you may consider generating templates and replacing entity placeholders with your own entity values such as food items, phone numbers, and addresses. Those entities can be easily extracted from existing datasets or generated using any fake data generators. Fake data can then be used to populate the templates for training or evaluation. There are several libraries and APIs that can generate realistic fake data, helping to produce large datasets. Using synthetic data avoids issues like privacy concerns that could come up when using real user records. It also provides full control over the data distribution and attributes, which is useful for experimentation and debugging NER models. There are many variations of phone numbers. For example, they may include the country code with a plus character, brackets, extensions, and more. We can customize or include any type of entity you want. LLMs can generate large amounts of synthetic data, allowing for the expansion of training datasets. This is particularly useful when real-world data is limited or expensive to collect. Not only sizing, generated data cover a wide range of variations, including different sentence structures, vocabulary choices, and writing styles. This diversity can help improve the robustness and generalization of NLP models. Instead of using a pre-trained model, fine-tuning the model on specific domains or tasks, enabling the generation of synthetic data that closely matches the target domain. This can be valuable when training models for specific industries or specialized applications. The quality of the synthetic data generated by LLMs heavily depends on the quality of the pre-training data and the fine-tuning process. If the pre-training data is biased or of low quality, it can affect the quality of the generated synthetic data. Besides quality, it may not always generate synthetic data that perfectly matches the target domain. Careful evaluation and fine-tuning may be necessary to ensure the generated data aligns with the target domain. In summary, using LLMs for data augmentation in NLP tasks offers benefits such as increased data quantity, diverse data generation. However, challenges related to data quality, domain mismatch and evaluation need to be carefully addressed to maximize the effectiveness of LLM-generated synthetic data.